Alright, we're going to be talking about parallel lines, specifically their interior angles. There's going to be a lot of information to throw at you on this one. So first of all, some vocabulary words. Between parallel lines, you might have a transversal, and it has a line that intersects them at two distinct points. And here's that word. Now, as far as what a transversal would look like, if I have two parallel lines, this red line connecting them would be an example of a transversal. Next, a postulate is an accepted statement of fact. So there's no proving postulates, it's just a true statement that we assume is true. And that is different than a theorem, which is also a true statement, but it's one that can be proven. And if you're in class, you're going to actually see me doing the proofs for theorems. For the video, though, I'm just going to be getting to the crux of the problems. These are the three different kinds of angle pairs that we're going to be talking in reference to parallel lines today. There are two others, but first of all is corresponding angles postulate. This is the accepted statement of fact. You can see that angle 1 and angle 2 are in the same location at both intersections between the parallel lines. The parallel lines here are L and M. T is the transversal. Angle 1 and angle 2 are both in the top right location, which makes them corresponding angles because they're in the same location. Anytime you have corresponding angles, they are congruent to one another, which means they'd have the same measure. Moving on to alternate interior angles, all interior angles will be between the two parallel lines. So 1, 2, 3, and even this angle right here would be interior angles. Now, as far as the pairs of alternate interior will always be on different sides of the transversal. So 1 and 3 are on different sides of the transversal. They're alternate interior angles. That makes them congruent. And lastly, we have same side interior angles. So 1 and 2 are on the same side of the transversal and between the parallel lines. That's the reason why they're same side interior angles. They are a little bit different in their setup. 1 and 2 are not congruent, but they would always add to 180 degrees because they are supplementary angles, which that vocabulary word is right there. So 1 and 2 are supplementary angles. Now, starting off with finding the measure of angle 1. If I'm referencing angle 1, I see that it is lying on the transversal C that connects it to 50 degrees. The parallel lines would be lines A and B connected by transversal C. Now let's find the measure of angle 1. 1 is in the bottom right location here. 50 degrees is also in the bottom right location at its intersection. So these two angles are corresponding angles. So on the previous screen we saw that corresponding angles are always equal. That's the reason why I've said that the measure of angle 1, lowercase m here, measure of angle 1 is equal to 50. That would be justified by the corresponding angles postulate. And that's when I know I'm done, is when I've actually stated the theorem or postulate that justifies each answer as the instructions said. So that's all I have to do for angle 1. Moving on to angle 2. If I'm looking at angle 2, I'm going to be looking at transversal A. Line A is going to be my transversal connecting angle 2 to 50 degrees. 2 and 50 are connected between the parallel lines C and D. And they are lying between those parallel lines, so they are interior angles. Now, because they are on the same side of transversal A, they are same side interior angles. My setup is going to be the measure of angle 2 plus 50 is equal to 180 degrees because they were same side interior angles. Now that's my setup. Every time you have same side interior angles, they will add up to 180. Now I do have to do a little bit of solving on this pair where I'm going to subtract 50 from both sides. That is going to result in the measure of angle 2 is equal to 130 degrees is my final answer there. Now moving on to example 2, finding the values of x and y in just another diagram. Very first thing I like to do is possibly highlight the parallel lines to really draw my attention to them. I knew that those were parallel by the arrows indicating as such. Now let's go ahead and take a look at x first. X is right here. It is in the top left location at its intersection. If I follow that transversal on over to the other parallel line, 70 degrees is in the top left location. X and 70 are corresponding angles. So I'm going to know that x equals 70 degrees. Again, that's by corresponding angles postulate. And you can see that I went ahead and wrote that information in right here just to help me with the rest of the problem. Now, that finishes it for x. For y, I could actually think of it two different ways. I could say y and 50 and 70 are making a line, and that's going to be 180 degrees. So you can see where I've added y, 50, and 70 to 180 degrees, which is a line. Now I could also think of it as 50 and y being one angle, 70 being another, and those two angles being supplementary because they're same side interior angles. If that's confusing you a little bit and you like the other way I thought about it, that's fine. Anyways, here you need to combine like terms. 50 and 70 makes for 120. And then I'll subtract the 120 away from both sides to get y equal to 60 degrees. And I'm done with y. Here on this last problem, I'm going to start by finding the values of x and y. Again, I'm going to be drawn to the parallel lines. I'm going to highlight those really quick. Now I'm going to focus on my transversals to make relationships. So let's start with 2x. It is related to the 90 degree mark because they're connected to the same transversal. 2x and 90 are between the parallel lines, so they're interior, and they're on the same side of the transversal. So I'm going to add them up to 180 degrees because they are same side interior angles. Now I'm just going to solve that equation. Again, every time you have same side interior angles, they add to 180. Start off by subtracting 90, so 2x is equal to 90, divide by 2, and I get x is equal to 45 as my answer for x. Now I'm ready to make an equation for y. Y is going to be associated with y minus 50 because that's the transversal that they're both on. When I take a look at y and y minus 50, they're both interior angles because they're between the parallel lines, and yet again they're on the same side of the transversal. So I'm going to set them up as adding together to equal 180 degrees because they are same side interior angles. Now that I've got that set up of adding y and y minus 50 equal to 180, I'm going now at combine like terms. Y plus y is 2y. I'm going to add 50 to both sides. So 2y equals 230. And then I'm going to divide by 2. And y is equal to 115. That's my answer for y. Now I'm actually not done with this problem because in the instructions it says then find the measures of the angles. So I've already got 90 degrees, that one's good. But I will go ahead and find 2x. And that will equal 90. Now how I got that was by doing 2 times the x value, which is now 45. So 2 times 45 equals 90. There's one of my angles, and now I'm going to also find my others. So y degrees I now have would be 115. So 115 degrees is the measure of this angle up here in the top right corner. And lastly, I'll do y minus 50. Now y minus 50 would be 115 minus 50, which is 65 degrees. And there's my measured angles. That wraps up the video. Let me know what questions you have. Thank you.